we're going to first look at number 15. So for each positive integer n, let d of n be the positive difference between the units digits of n squared and the quantity n plus 1 squared. And we want to compute d of 1 summed all the way up to d of 100. So there's a lot of values here. There's 100 of them, and we have to sum them all together. Now, doing that manually, it's going to take a bit of time. So let's see if we can find some patterns. Now, the first thing we notice is that we only care about the units digits. So if we only care about the units digits, that means that d of 1 is going to be the same as d of 11. And that's because the units digits of 2 squared minus 1 squared and 12 squared minus 11 squared are the same, right? They're both equal to 3. So that means that we only need to calculate it over periods of 10 and then multiply that by 10. So that helps a little. But if we take a further look, right, and we go within that period of 10, we have d of 1, d of 2, and then let's just write all of these out. D of 5, 6, 7, 8, 9, and 10, we'll notice that there's another pattern. And that is that within each group of 10 consecutive integers, we have another repetition. And that's because the squares have a cycle of units digit, right? So for d of 1, that equals 3, since 4 minus 1 is 3. D of 2 is 5. D of 3, you might think is 7, but remember we want the positive difference between the units digits. So that would be 16, and 9 gives us 9 minus 6 is 3. And then for 4, we go from 16 to 25, so that's 1. And then finally 5 to 6, we have 1 again. So for that, we then see that d of 6 from 6 to 7 is 3, 7 to 8 is 3, 8 to 9, I think there's 6 to 7, 36 to 49 is 3, 7 to 8 is 5, not 3. And then from d of 8 is the difference between the units digits of 8 squared and 9 squared, which is 3 again. And then finally, d of 9 and d of 10 are both 1. So we notice that this pattern repeats for every 5, which means that this sum right here, the summation from, say, I equals 1 to 100 of d of I is actually equal to 20 times the summation from I equals 1 to 5 of d of I. And we know that, right? To find this summation on the right over here, we just need to add together 3, 5, 3, 1, 1, which using addition, we can do that. And that allows us to compute this expression on the right to be equal to 20 times 3 plus 5 plus 3 plus 1 plus 1. Inside the parentheses gives us 13, so 20 times 13 gives us a total of 260, which is our answer, and that is answer choice C, 260. All right.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.